When you care about something, why can't it be done better? We get a repertoire of all the manufacturing process. Can I do it smaller? Can I make it more accessible? This is a secret for the podcast. Actually, we couldn't find any trash.
Because the government had cleaned it up.
Everyone says one thing right about recycling or upcycling or transformation is that it costs a lot of energy. It does have a lot of environmental footprint. For example, you do e-waste recycling. Just imagine you have acid wash, base wash, just to get some gold and platinum or copper out of that circuit board.
Yeah.
But you're washing away all that glue, epoxies, right?
Glue, mercury,
Yes, all that stuff.
Yeah.
So that has to be discharged, right? And so there's only two ways of discharge, unfortunately, in the world: air or water. Air is basically you get temperature so high it becomes gas, or you dilute it. So in either way, to me, that is not even an environmental remediation.
Yeah.
But that's what the world is being, certified. Saying that, oh, this is a clean factory. Oh, that's just because you discharge at a much higher dilution rate.
Yeah. You put it into a tank, and that tank has like got certain chemicals that then make these harmful chemicals less harmful.
Yeah, and
but they're still harmful.
You just keep adding water. So the chemical footprint, that's why our ocean gets worse and worse and worse and worse.
Yeah.
Air gets worse and worse and worse. It's not getting better. It's because there's no real solution to take away, unless you shoot it out into the space.
Yeah.
These things are still there.
Yeah.
It just transform into different form.
All right, so you go from you're an architect, you're an engineer, you're building out these plants, and then you say, right, okay, we've got to like change this mindset, which is making these recycling facilities mobile, right? So that you don't have to truck it hundreds of kilometers to get it to that plastic recycling plant. You don't have to ship it to another country. So what was the first?
The first was like in 2015, because the biggest hurdle for recycling, other than the environmental remediation footprint, is the transportation. When we are in the upcycling business, we're transforming the material. They're very important to have the trash at the cleanest state. When the trash is the cleanest is when you just finish using it.
Right.
So you need to shrink the distance between that. When you mix things together, it becomes harder to separate.
Yeah.
The costs become higher. The quality of a final product also become lower.
Yeah.
So how do we decentralize that to get the plant as close to the people,
source,
to the source as possible?
Yeah.
And so during that time, we do have an amazing opportunity in Tibet, in Qinghai. We got a letter from the lamas saying that in the high mountains, the Sanjiangyuan, which is the three-river basin of Yangtze, Yellow, Mekong, so which is powering the whole Southeast Asia and also East Asia. And these river systems at 5,000 meters are actually being polluted with plastic trash.
Yeah.
And so a lot of cows are eating it. And so he's giving me these horrible photos. And I showed this photo because I was working on a project with Jackie Chan at that time. He's super into sustainability. And so I showed him this letter from Tibet. And then he was like, why don't we do something with that? And I said, yeah, but we need to decentralize it. We basically took some of a budget from his and our construction budget.
Yeah.
We just start making the machine. And then we tested in the 5,000 meter, and we tried to take the trash there and build the school.
Yep.
And I mean, we did try. I would say somewhat successful, but it has so many problems.
You have to try and you have to fail, because failure drives you towards, the right solution. And so you make this first like Miniwiz machine.
Yeah.
You've got some success in building a school. What was the learnings from it? What was the next project? And was that more successful?
No, but so we actually invested in 3 sets of machines, and unfortunately they're all solar power. So back then, you're so idealistic. We all have all these smart battery control system, biodiesel sub-generators to power the whole plant, 17 kilowatts. So you want to reduce the energy footprint. And so you have to be very frugal with your energy usage. But when you're in the portable setting, decentralized setting, this become very crazy. It's kind of like having a first generation electric car with solar power. Till this day, the electric car is still not solar power. You see what I mean?
It's not enough power.
It's not enough power. So all the smart ideas get taken out one by one. So the first 3, I would say, wasn't very successful because it's energy powering system.
Yeah. you were probably trying to focus on too many things. Reducing the energy, making it
The
clean
footprint,
energy,
yes.
and recycling and getting as much sort
Yes.
of like throughput of recycled materials,
Yeah.
but you can't solve everything
Yeah,
all
exactly.
at one time,
It
right?
was too ambitious, yeah,
Yeah.
and portability, and we also miniaturizing because once you talk about transportation, it's about miniaturizing. So you had to take what we did before, and you got to shrink it down by level of 10. Everything is an issue, and a good thing and a bad thing. It was documented by Nat Geo. It shows our failure because we did not even design a proper machine that can go on the road. So the machine all crashed into the truck, and then we had to fix it, blah, blah, blah. In the beginning, when you're like full of like energy, you're stupid, and then you have so much good idea. I don't mean good idea is good, right? So like, I mean like
It's good at the time until you figure out,
right
damn.
right thing to do, right?
Yeah.
The right thing to do. Finally, you get to do the right thing, right?
Yep.
And then everything failed, like in your face, you know. But at the end, from the documentary side, from the impact side, the Chinese government are quite interesting.
Mainland Chinese government?
Yeah,
That's how they discovered you from that
Yeah.
Nat Geo.
Nat Geo, yeah. So
documentary?
because we are applying for a license to be able to film
In Tibet.
in Tibet. I'm so glad we did that. The real impact, it does not come from the machine. The real impact come from because we're going there. They built a recycling system at 5,000 meters before we got there.
No way.
Yeah.
The Chinese government.
Yeah.
Wow.
So like they basically took the typical recycling plant in the flatland, they move it up. By the time we got
And
there,
cleaned up the river?
yes, this is a secret for the podcast. But if you see the documentary, actually we couldn't find any trash.
Wow. Wow.
Because it was already cleaned up.
Because the government had cleaned it up. You know, I have only respect for how fast the Chinese government can move. When they want to make something happen, it's just like bang, they'll do it. So how long did
4 months.
4 months to build that plant?
Yeah, they built a plant, everything clean up.
How big was that plant?
The plant was like 5,000 meters. It just have a manual sorting line, and it does have a compressor. They basically bale all the trash into paper, plastic. I mean, it's just baling. It's not transforming.
Yeah, sure.
You know, of course, Miniwiz is definitely responsible for the transformation side. And then after that, we hit COVID. So we never really got back to do the transformation again.
But there must be still a project there, I guess, to take those bales, turn it into some cool stuff like sunglasses or these great like finishes and materials.
That was the original goal. Like all the souvenir can be made from that, and then they can include with the local artisans with the arts and craft embedded on it. So imagine you're pressing into a block, and that block can be carved into different things. And you can see the third or fourth generation, the fifth generation of our machine now is already that.
It can do it.
But right now it's used a lot less energy, 4.7 kilowatt hour, slightly bigger than the air conditioning power requirement. That's number one. And then it can be much more portable.
Yeah.
And it also can do a lot more.
Yeah.
So and the efficiency is actually higher.
Yeah.
This is probably the craziest product it can make because this has metal embedded joints, auto ejections. It has embedded grooves. It just has a incredible strength because of tonnage, 450 psi of pressure squeezed into a very small footprint.
So does that pressure overcome the fact that it's not completely homogeneous plastic?
Yes.
It does.
Right now, it doesn't have to be homogeneous.
It doesn't have to be.
Right now, this is all mixed material. This has PET, PP, HDP, all mixed together. And they are not chemically bonded with each other. They're literally just mangled together.
So the structural integrity of something can be achieved through compression.
Yes, the whole world, the most of the material is actually done through compression. It just mango giant hairball because of the pressure they couldn't come out. This is a kind of like a giant random material felt. So in this
pressure and heat, obviously.
Heat is just to increase the material flow a little bit.
Right.
You turn into a dough, but the dough is not gooey. It's not watery.
It's not like water. It's like dough texture.
Very heavy dough. You have to roll into a ball, and that ball gets squeezed into a precision mold. That's why we call it the Trashpresso. So this morning you're making coffee to me. So hopefully, when you come to Taipei, I can make Trashpresso.
Trashpressed espresso like grounds
for you. Yes.
Yeah. Cool.
So it's just squeezing. So that process reduces. So no longer uses water, doesn't have fume because the temperature is so low, way below the softening temperature, and the melting temperature.
Was that something you learnt, or you saw someone else doing it, or was it just trial and error?
There's a combination of high conceptual understanding of how materials made.
So you thought, okay, felt can do this. Why can't we do it with plastic?
We learn it from aluminium. Metal work are mainly through pressure. They're not through chemical bond. The key from the beginning of this is because we don't want air pollution. If you anyone gone to a plastic factory, I'm 100% guarantee you, you will get dizzy. When I go to a plastic plant, I get dizzy like right away.
Wow.
Yeah, you can smell it right away. If you want more people to understand what upcycling is, what transformation is all about, you cannot get people sick. If you want to get the kids to learn about this, you cannot get kids to be sick, right?
Yeah.
So taking out pollution, if you look at going to a aluminium forging plant, there's no air pollution, but there's noise, huge amount of noise, because they're dropping it like about 9 meters and down. The sound is deafening. Like you go deaf if you go to
Trashpresso is like a small machine, but it's making huge noise.
No, so we don't have noise.
Wow.
So how do you do a slow forge? So you see what I mean? Like these are the two things that's limiting its potential to decentralize. So if I can solve those two problems, then it can decentralize. And then the last is transportation. When you see the machine can be transported easily by hand, industrial trolley, all that stuff.
So you've done plastic, which is through compression technology, and then this is actually from airside.
Yeah.
So which is Nanfeng was the developer. Maybe you can see there's a bit of 3D here. How was this created?
So this is created by probably the oldest technology, which is called the hairball. It's a needle punch. With the new generation of needle punching machine, with a different feeder, you're able to control the density very well. And that's how you can get sound acoustic quality.
Yeah.
With the new generation engineered fiber, which this is done with the 50% engineered fiber of recycled PET bottle. You see a lot of felt insulation material has some of that, except this one is infused with phosphorus for fire rating. It also has a lot of textile waste. Needle punch is an old technology, but we added, for example, extra digital loading bay. So you're able to put in different color. Because normally...
So what was the raw material and what color was it? Because this is like orange.
This is 8 color because Nanfeng and Stoneheader, which is the chief architect, they wanted to have this copper look. And because of that, they want to create this color palette. We had to come up with all 7 or 8 different color yarn, the short fiber, to be able to mix together in a very digital way to have a kind of a general feel. Why it looks premium is because of its layer of color and the depth of a color. And then additional, you can also see the texture. That's also a custom rolling pattern that we designed for Stoneheader.
Yeah. Because this is for a project in Hong Kong. Where was the manufacturing done? And where did the feedstock come from?
So, unfortunately, we only took some tiny bit of feedstock as a symbolic from Nanfeng. We took a batch of bottles. Most of our feedstock actually is from Taiwan waste.
Right.
And then we produce a massive custom volume of fiber with the phosphorus embedded inside. Then we turn it into these panels and wallpaper.
Did you already have the machine for this?
Yes.
So using the needle punch.
Yes, a needle punch and then with a different roller, so you can have different pattern. And roller can never get that hard. And then you can add the giant heat press. Then you can turn it into a board. The roller is just one set of machine. So there's different way of heating at roller. Depends on what type of heating you want. You can be fire heated, which is very different from the thermal heated, like internally thermal induction heated. We call it a burn. Different pressure create different pattern too. And then the roller can have different pattern. You can roll in different...
So you got to create the custom roller with the pattern and stuff. You've actually put phosphorus into this to be able to deal with the fire rating.
Yes. So it's 100% recycled polyester, B1 grade, fire rating, but with gypsum behind. Together as a material is A1. And also sound insulation quality is between 0.4, which the sound. 0.4 to 0.9. 0.9 is crazy with gypsum behind. Just regular plywood still get to around 0.6, which is not bad.
It's really good, not just because of the material itself, but it's also the 3D structure.
Yes. What we call amorphous, the holes inside. And unfortunately, you're the expert in this. Soundproofing and fire is totally counterintuitive.
Yep.
Because every time you have holes, you have air pocket. air create fire.
Creates fire.
Then it's burn. So this is easier.
Yep.
Because when you compress everything, so there's no air inside, which is really good fire rating.
Yep.
But when you have that sound quality, that's why phosphorus content, the density of phosphorus become very crucial. One of the things is who can do that type of chemical engineering these days, because no one really wants to do 100% recycled polyester, right? So they normally add rock wool, right? So which is mineral wool, right? So you add mineral wool, pretty much you don't need to care about the phosphorus embedded into the recycled polyester.
But then you got the problems with the filaments, and then that that can pollute the air and the air quality and all that kind of stuff. These are some other products so this is like an aggregate.
Oh yeah, but I think this aggregate, most audience probably would not recognize what this is. This is actually electric insulator. Ceramic electric insulator. It's actually everywhere in the world. Anywhere there's electricity, you're going to have electric insulator. And there's a waste. Huge amount of waste. Like every 10 years, they have to upgrade.
So then this would become like a wall tile, floor tile.
Floor tile. This is a typical pressed cement tile with a 9 hardness level. So it become a very hard tile. I think what's very interesting is we created this kind of shadow. It's because when you sanded them, they created this 3D effect also. And it looks like it's manually placed, right, as a mosaic.
I mean, this is very cool. Does every single tile look different? Like, I mean, are you able to control the amount of white and gray and cream color in here? Or that's just purely up to the feedstock?
No, purely up to the feedstock. But then we do separate the feedstock into colors. And so when they're going in there, so they're actually feeding them in differently. So there is a general tone.
Cool. Okay, so this is upcycled aluminium.
Yes. So this is our basically hospital projects, trying to create these hospital wall system, just aluminium. This system has to be able to take A1 grade because behind it is just oxygen pipe. And most of a hospital now is because all those oxygen pipe and electric pipe are all hidden inside the foam concrete.
Right.
Because you can imagine electricity,
and oxygen.
UPS, and oxygen.
Boom.
They are just not a good combination. Because of these encasing property that they need to be encased, that's why hospital could not be upgraded. And also cannot have these what we call very easily contained interior spaces. Because of this wall paneling and the clipping system that we designed for that, we are able to have these quick fix panel, allows for all the pipes in the back to be exposed. And so we built quite a lot of hospitals with this system. And I know it's a very simple logic. Come on, this is everywhere, right?
But it's made from upcycled aluminium.
Normally in Taiwan is at least 60%. So what's interesting is we actually go buy the ingots from the recycled ingots, then extrude it into plates. These are rolls, and then they are actually then folded. Also a machine to glue them. So there is actually some glue in it between.
Yeah, it's very cool. Speaking of this in hospitals, during COVID, you actually created these mobile hospitals.
Well, they're not mobile. They're actually fully embedded. They're still functioning right now.
Right. And that was because during COVID, nothing could get imported into Taiwan. So you had to material science, architecture, combine all of your knowledge to design these much needed hospital beds and locations.
Like again, this is all because necessity, right? Because during that time, the government wants to build a COVID center in Taipei, but none of the material can be imported because it's all embargo at that time. All medical goods are embargo. We are the only hospital got built. We are also the COVID center. And then during that time, all the COVID patients in Taipei City actually go to that hospital. And I think we saved quite a lot of people, according to the doctor, by data.
What were you recycling and then making?
Okay, aluminium, which we already have. Okay,
so
which
this
is
was this. This is one of the materials.
One of the material. Then we also buy sterilized PP from medical recycler, and that's extruded into these clipping joints for the aluminium panel. So the fact that we are able to have these recycler. We also have the know-how to be able to, and the machine to be able to create those material during that very short period of time, within 8 months. We are lucky because we're in Taiwan, because I don't think you can do that in most places.
I mean, sort of wrapping up, actually, if you think about Rome at that time, when they were building those cities, they weren't able to import stuff from all over the world to build the city. So what did they have? They had the trash and the things that people had wasted.
Yeah.
And then they could compress that, and then put the nice finishes on the
Yeah,
outside. I mean,
yes.
if you look at this,
Insane.
this is a nice finish on the outside, but then this could
Inside.
be all the trash
Yes.
in the middle, right?
Totally.
And that's exactly how they were building at that time.
So if you cut open the wall
Yeah.
of these old Roman houses or like these even churches, inside is all amphora. Amphoras, they're single-use packaging.
Right.
They got the grain and the oil from Greece and Egypt. They have these like funnel, right? Like in a wooden crate. And then they break after they use it because these are porous material. So the oil gets stench, right? It's sucked into the pores. So they don't use it second time. So the single use, they break it and become building material. So that was definitely kind of what we're doing too.
In everyday life, we can go back to that Roman method of doing things where we construct things out of the trash. And by doing it in a way that you guys are doing it, I think there's so much that everyone can learn from it. But I just want to thank you for everything that you do. You're an innovator. You're certainly a motivator to me. So thanks, Arthur.
No, thank you, Jeff, for inviting me. Thank you. Cheers. Wow, nice. You're the perfect model for that.